All right. Well, welcome everyone to the Virtual MLnet Fall Edition. We're doing a hackathon this time, and we're back after about a half a year being away in the middle of this pandemic. But we're excited to be back and have you and do a little twist on the conference we did last year. And with us today, we have kind of the same crew as we had in the spring here. So, guys, do you want to introduce yourself for people?
I nominate Louise first.
Oh, all right. Yeah, sure. I'll go. Hi, folks. I'm Luis. I work at Microsoft. I'm part of the Microsoft Docs team, working across various products, including Azure Machine Learning, ML.NET, and .NET for Apache Spark.
Bree, you're next.
All right. My name is Bree. I work at Microsoft. I'm the PM for ML.NET. And I'm also Malibu's mom. She may appear on the stream at some point. She's feeling a little camera shy, but I'm sure with enough treats, she'll come by and say hi. Hand it over to John.
ML.NET mascot.
Exactly.
Not John, Malibu.
Or both, who knows?
I'm John. I'm a software developer by day, and by morning, because I'm more of a morning person, do ML.NET stuff and work on some YouTube videos.
Awesome. And I'm Alexander Slotte. I'm a Microsoft MVP all the time, but I work at Excella in DC most of the time otherwise. And I love ML.NET and have been working on the MLOps.NET tool for the last couple of months. Awesome. Well, you have the crew here, and we are ready to get started. So the agenda for today, to get you all kind of into the mood here, is that me and John, we're going to go over the rules for this hackathon, walk you over what kind of submissions there already is, so what kind of projects you can start working on or you can join if you don't already have projects, as well as some thoughts on how you will submit your proposal when you're done. But we will reiterate this as we go along. But the submission deadline, I believe, is at the end of Wednesday next week. And we will be announcing a winner on Friday next week, the 20th, at 11 p.m. Pacific time. So 2 p.m. Eastern Daylight Time. So that's the schedule you need to know. But after we're done here with the kind of the rules and walking through the submissions, Bree and Louise will take you through some ML.NET goodness and demo some stuff and get you started with the library if you haven't already tried it out, or if you have no background so far with it, or if you just want a refresher. So I think that's the agenda. And John, should we get started with the rules?
Yeah, we can. So you have them up, or there you go.
We have them up here. So we have a repo, and everything you need to know is on the repo. So if you have any questions, definitely always go to repo. But yeah, the hackathon rules. John, do you want to go through them?
Well, first and foremost, just definitely this is something to have fun. And I would add in there something to help you learn some ML.NET or machine learning in general. So I think that was number one rule that we hope you take away.
Exactly, yeah. And the thing here is everyone is welcome, right? And when you submit a submission to this hackathon, don't worry about having it completely complete, a functioning web app or a functioning model or anything else. You can also just have the idea and the embryo, if you will, of that to submit. Because we realize you all have full-time, daytime jobs as well. And we just want some really cool submissions with ideas. They can still win this whole competition. So just don't forget to submit, even though you're not complete by the end of the week. You can create your own team, as we'll see later, and submit something. You can also, of course, you can join a team if a team is looking for teammates, and we'll go over that process in just a little bit here. But remember that everyone needs to adhere to the code of conduct, and we're using a standard code of conduct. And if you are interested about reading more into details there, definitely check out the hackathon rules page here, and you can then go to it right here. So John, should we look at how we can submit the proposals once they're done, or the submission?
Sounds good.
So for the final submissions, right, we have this submissions folder here. And for the ease of use here, we have created a README file for you to read through on how to submit this. And you can go into the details as much as you will here. You can reach out to any of 4 of us for more information if they're not clear enough. But in general, right, John, and this is kind of in your court here, it's about creating a 1 to 3 minute video, right?
Right. Yeah, just something to either show off what you've been working on, or if you contributed to like ML.NET repo, just kind of go over what issue or what new feature you did, and then kind of show off the changes that you did with those.
Exactly, yeah. And if you, when you do the video, go ahead and upload it to Dropbox or Google Drive or somewhere else. You can share it and add the link to your submission instead of the full video. Because if you, create a PR and so forth, and we decide to merge it, it will just increase the size of the fork, or if anyone else wants to clone this repo. So add a link to your video and some descriptions, and that would be great. And you can create your own folder here for each team, and just kind of fill in this template here, so we have an idea of what you've been working on. And again, if you have any questions on how to submit at the end of next week, reach out to us, and we'll be more than willing to kind of guide you through it. And another thing I want to mention here as well is that if you have any questions during the hackathon or afterwards, go ahead and join the Virtual ML.NET Slack community if you haven't already. This is a Slack community we created in the spring, which you can engage with me, John, Bree, Luis, or anyone else in the ML community that have already joined there, either through various channels, for example, Hackathon 2020 for this event, or the general channel if you have questions around ML.NET, or want to get started or something like that. I know that there's a lot of good questions lately. I know Journey has been asking about ARM support, I believe, as well, in .NET 5 and so forth. So a lot of these things that we may be wondering about can be clarified there, I think. And if you want to get started with useful links here as well, we have a couple here for datasets that may get you started. We also have a link to a workshop that we gave not too long ago here for ML.NET, for NDC, I believe, which will take you through more or less every part of kind of ML.NET's features, everything from data, training, evaluation, Onyx models, and so forth. So if you are getting started with this and want some kind of content or samples to use, this could be potentially a good place for you to get that. All right, John, should we go through the submissions so far and see what we have?
Yeah, I'm excited.
All right. Well, Luis, nice, very, very nicely added some labels here this morning for which issues or projects here are looking for mentors and which ones are looking for teammates. So if you have signed up for the hackathon already and don't have a project to work on, we all suggest that you look at these teammates wanted labels and start commenting on those, saying that you are interested, and then kind of sync up and connect with the person who submitted the idea. That would be the best way. But we'll walk through the ideas real quick here and kind of see what we have here. So the first one submitted, and I think, John, let's do every second one, if it makes sense to you. But the first one we have here is by Gregor here, about a Twitter DM filter, a so-called silencer. I love the trademark symbol here. So it's a browser plugin to filter out hateful messages from your Twitter DMs. And I don't believe he's currently looking for teammates, but you can always reach out to him if you're interested. Well, he said, I don't know yet, so maybe he's looking for teammates. So if you find this idea about a Twitter silencer interesting, definitely comment on this issue and connect with Gregor. All right, John, do you want to go over the face mask idea here by Brett?
Yeah, Brett put this in. Although I think later on he said he won't be able to kind of complete this. So, but it's still out there. If anybody wants to kind of take the lead on it, then feel free to do so. But we have a face mask detection.
Yeah.
So he wants to do a Blazor app with a webcam input, and it'll determine if anybody's wearing a mask or not. So pretty good timing with all the pandemic stuff. So sounds interesting, especially with the webcam and it sounds like an object detection problem here.
Yeah, I think it's a great idea. Could definitely be, a real time, real world applicable. Maybe you can have a camera in a convenience store, and it alerts you if someone enters the store without a mask, for example, and or just kind of enforce guidelines. So this is a cool idea, I think. So if you think this is a cool idea as well and want to work on it, you can definitely pick it up, and I'm sure Brett would love that as well to get that implemented. So the next one here is by Daniel, and I think it's to do with smart labeling. Smart labeling classification data sets, mixing machine learning with deep learning here. And I believe he is looking for, and he has done a really good job here providing some nice diagrams as well. And I believe he's looking for teammates. So this is a really fun and cool idea here. I know there's already been people reaching out to support Daniel here. If you are interested in supporting him with some smart labeling using multi-classification and deep learning, I believe, then I think this is the idea for you. And the next one, John?
It's like a network detection for malicious attackers. So looking at some network activity and kind of classifying if the activity is malicious or not. So a nice little kind of a binary classification problem there.
Absolutely, yeah. This is a really cool one, and I was looking at the comments here, and Michael definitely got a lot of traction on this idea already, with a couple of people wanting to chime in here. So definitely a really cool idea here. I look forward to seeing that submission. I believe this one was just a template submission without any information. So Aminu, if you are watching this and you want to have people in this idea, feel free to provide some more information about this idea as well here. So I'll pick up the next one then. The next one is by F. Varis, and it's about interactive data exploration and model construction with F#. So that's really cool. Can I put in some F# in here? I know Luis is working a lot with F# with ML.NET here. Faisal Varis, yep. So that should be cool. Let's see. Reading this through a bit as well. Okay, well, that'd be cool. I think if you are, he's not looking for teammates right now, but this is an idea I'm looking forward to seeing more about as well, and seeing what this will yield as a result.
Yeah, it should be good. I'm glad somebody's picking up some F# with this as well.
Yeah, always excited to see that for sure. All right.
Let's see, we've got one from Frank, something gaming related. So that should be interesting. Let's see.
Yeah, I was reading this morning about this one. It got me really excited. Yeah, because it had a Red Alert in there, and I remember playing Red Alert when I was younger.
I don't think I played that.
It's an age thing. No, I think, well, yeah, it's definitely like a gaming related thing. I think it's about adding machine learning and deep learning to like older games. And there's something, I think, initiative rewriting classic games in C#. And I think this is about adding some AI to like older games like Red Alert or Tiberian Sun and those things. So this should be a really fun one, actually. I really hope something comes out of this one, because I would love to see the video showcasing how this is working. Cool. All right, so he's potentially looking for teammates. So this could be something, if you're a gamer or interested in this, you should kind of chime in here. Journey is looking at the track, classify, and manage devices based on power usage. So I think Journey is seeing a spike in his electrical output demand at home, and he was looking into how he can save power consumption in his home. So he's looking at some kind of IT solution, I think, here with smart devices, and I think streamlining, if I'm understanding correctly, when to kind of reduce power consumptions on devices and so forth. This sounds like a very real world applicable idea, and I was very impressed by Journey here, because he has already added exact power consumptions of like his computer in idle, 110, and normal usage. I was like, wow, especially like hibernations. Like, where do you get all this information? So that's very impressive. So it's very spelled out, I think. So that should be a cool one. And he has a smart plug he's going to use here as well. And Journey is looking for teammates. So if you want to do some IoT with smart devices, this could definitely be one that you want to chime into. John, what do you have to say about this one here?
Desktop application for object detection. So unlike Brett's idea using a web app, this one's going to use kind of a desktop app. I'm guessing maybe WPF or maybe WinForms. Never know. But yeah, it should be good. Just taking in from the desktop, the web camera stream, and then detecting objects with it.
Yeah, that should be a great one as well. Looking for teammates. So that's something that you definitely should start commenting on if you want to contribute. And let's see, we are on chest X-ray disease detection, I think. So Jinka here has an idea about classifying X-rays for chest disease for various reasons. This is a great, image classification example. We can use AML.net to do that. Should be a fun one for sure. Using some deep learning and potentially, either in this case you can either, I guess, train your own model using AML.net with transfer learning, or using an Onyx model as well from the Onyx Zoo to do this. So that should be a fun one. We'll see kind of which direction this is going in. So that should be a fun one. And John, what do you think about this one?
Some text analytics for education and learning. It should be interesting. I'm looking forward to seeing how this turns out too, because I'm always interested in how you can use machine learning to help people learn better or faster.
Absolutely, yeah. So he wants to determine if something is a story and what the text is about, and get some meta model information about the text as well here. I haven't spent too much time into natural language processing with AML.net, so I'll be curious to see kind of what the limitations are and how far you can take this idea. I'm sure you can use a lot of pre-trained Onyx models for this as well, but I would be curious to see where you can go with raw AML.net, if you will. All right, we're getting to the top here. So we have a photo bomb idea here by Paul, I believe. I like the title here, photo bomb. So let's see here. It's about image classification and tagging, I think, right? So he wants to go through photos in a given folder, add tags for all objects found in photos, and then he wants to make them searchable in Windows search using those tags. So it seems a bit like, Google Photos on a Google phone. You can search for, in your photos, you can search for cat or table, and it will show all the pictures with a cat or table in it, which I think is really cool. So this would be a really cool feature if they kind of be done using AML.net. I can definitely see a good use case for this for sure. That'd be cool. Awesome. Mm-hmm. Looking forward to hearing more about that one. And I think we're on this one.
Let's see, image classification application. Train model on images loaded from different catalogs. And he wants to use React as a front-end application, so that'd be interesting.
Mm-hmm, yeah.
And then making predictions on images from that catalog. So it's like like you mentioned in the title, image classification. But okay. It'd be interesting to see how he hooks it up with React as well.
Yeah, absolutely. Well, good luck, Rafael. All right, we got automatic stock trader here. So Joey wants to predict stock prices, I'm sure, and do automatic trading here. Stonks Inc. I like that name. That's a good one for the team here. And it's not looking for teammates right now, but it's going to use the Alpaca API to build a stock trader that will learn from past stock prices to predict future prices. Interesting. I never heard about an Alpaca API. I guess that's an API for stock prices, I assume, for real-time information. Most likely. I'm just guessing here.
Yeah, I haven't heard of it either.
Yeah. But that'd be great, especially if we are, if we're able to integrate real-time data here with this model as well to do real-time predictions. That's something that's really cool. So, Joey, I would be very curious to see how you're going to implement both the the model training part, but also the real-time prediction pipeline part here. So, interesting one. Opened yesterday. All right, got 2 left to go here. So we have an earthquake detection monitor from Mustafa.
So seeing if we can detect earthquakes automatically with ML.net. I'm curious to see what kind of data set he'll get with this, because it'll be interesting to see how he can do that.
Absolutely, yeah. I'm also curious about the data set here. So all these ideas are really, really cool, and I'm always like, the first thing I think about, okay, what's the data going to be used here for this this specific model here? But yeah, this is going to be really cool to see how it plays out as well. Especially I think we had 2 earthquakes today as well in the US. So that's a very timely idea, I guess. Submitting it right now. And the last one that was open just an hour ago is from the Sumet and Rohan from Team High Five. So they're going to try to do predicting and improvising system service cache load using machine learning techniques. Okay, nice. So, cache, of course, used to reduce load on database servers and server requests. And I guess we're trying to make the caches smarter. I'm trying to read through the description here. Okay. Okay, so I think it's more about load testing, I guess. So predicting how many customers can potentially visit bank or use a particular service, indirectly predicting a load of a service or caching system. Okay, so that would probably be useful for scaling up, scaling down, cost control probably as well in many ways. That's a great idea. Absolutely.
Yeah.
Potentially a lot of cost savings there for anyone who can use that algorithm as well. So fantastic. All right. Well, those are the 16 ideas we have submitted, which I think is amazing in many ways. And we have walked through some of the rules and some of the things here in general. If you have any questions here, they're always this one the first to refer to. But before we jump into more of an in-depth introduction of ML.net by Brie and Louise, we want to open the floor to all of you that are currently on the stream for a question and answer session regarding the hackathon and rules and so forth. So if you have any questions currently about the event itself or anything revolving around it, please put a question in the chat, either in YouTube or on Twitch, depending on where you are currently streaming and listening into this. And we will do our best to answer it.
And I know we have a few already, so let me change the view here. This is just us. So Sayrol asked, can you define what a new project is?
So a new project, that's a good question for sure. I guess a new project is something that you haven't really been working on, on your company, for example. It needs to be open source, right? So we can kind of review the submission. If you have been, working on it from start to finish for months and months, that's maybe not a good candidate either. But it doesn't mean that we're ruling out certain things. Like, you can definitely contribute to existing projects that are out there. So you don't need to create your own model or solution. You can also contribute to existing projects out there. So for example, if you want to contribute to the actual ML.net repo, you can do so by sorting for issues that you may want to do. And then you can submit a solution to an issue instead as a solution or a submission. And that would definitely qualify as well as a good idea. And if you're new to, for example, contributing to ML.net, it can be very daunting to start with because there's a lot of issues. But you can filter down here for I think first good issues, good first issue, or up for grabs. And you will find a couple of ones that are most likely very flushed out and straightforward to do. So this is definitely a good start to do that. And you can also contribute to something like the machine learning samples repo here. So if you rely on samples to learn ML.NET, definitely think about contributing back as well. If you've done something yourself and want to get at, you can also do that here. Or I'm just going to, for myself here as well, say if you want to contribute to other kind of tooling in the community, like MLOps.net that I try to work on a lot, that's also very welcomed as well. So hopefully that answers the question about new product or not a new product.
Awesome. Another great question here, learning.net. So far, these projects seems outside my capacity. Any beginner or learning level projects?
Good question. So I think, first of all, the important thing, I think, and John, definitely chime in here if you have some thoughts, or Luis and Brie as well. But from my perspective, pick one that you find interesting, even if it's just going through a sample, existing sample on Kaggle. So, for example, Kaggle is a good place to look at previous competitions or ideas or sample data. I would just encourage anyone to just start with wherever they feel comfortable and submitting that. And no one knows how far that will go.
Definitely. Louise, if you're talking, you are muted. We had to have it happen at least once.
Right. Yeah, sorry. There's just some work being done outside my window. So, but anyway, as I was saying, we have some samples, right? Machine learning samples that are part of the repo. We included a link to it inside of the in the README, right? So kind of go there to the README. And you can check those out, right? And that could be sort of your starting point, and then you can sort of try to mold that to your idea, right? So I would suggest start with an idea, perhaps take a look at and take inspiration from the samples that are out there, and then just tweak it to your use case.
And I would like to add to, even though they seem outside your comfort zone or capacity, if it's interesting, go ahead and still give it a shot. I mean, you don't have to finish the project to submit. You don't have a week for the hackathon. So, and even after the hackathon ends, feel free to keep on hacking on your project, even after submitting.
Definitely. All right. We've got another question here from Nulio7. Is there a scoring matrix for the submissions, or any hints you can give about how these will be scored?
Great question. I think I'll speak for myself, and kind of what we talked about as well is that it's kind of all about community impact in my book, at least. Whether that is a new way of implementing ML.NET, whether that is an existing way of doing that. As John alluded to, it doesn't need to be fully functioning and working if it's a really good idea with something that can be built on, or a use case that no one has looked at before. Scoring matrix? No, we don't really have one. I guess it's a short answer. But really, John, do you have anything to add to that?
Yeah, I would add that certainly, if it's a really good idea, we'll consider that, right? But of course, we also want completeness. So of course, something that is working and it's a good idea, that's creative, that makes perhaps like Alexander mentioned, that makes a big impact, right? Like those are the things that are being considered here. But again, just because you don't finish, that also won't necessarily rule you out, right? So.
And to that as well, like we want to mention the prize, right? That I forgot we didn't mention the prize of winning. So the prize of winning the hackathon is that you will be invited to the machine learning.net community stand-up that is bi-weekly, and present your solution and your submission to the broader .NET community, which I think is a great opportunity to show that off.
Yeah.
All right. And another question from Nulio7. What is the last possible minute you could set in your submission?
So I believe that we have put the deadline to Wednesday at 11:59 p.m.
Pacific time, specifically.
Yeah. Oh, Pacific time. Okay, sure. I will personally accept any submissions that is in before I wake up on Thursday morning.
Yeah, we won't be too strict on that, but yeah. I think we're going to get together on Thursday, and that's when we'll go over them all. And then I don't know if Alexander mentioned this already, but on Friday when we announce the winners, we're actually going to go through all of the projects as well, all the video submissions before announcing the winner.
Yep, good point. Yeah, we're gonna have a little, Oscars award ceremony there.
Or the Dundies, if you all know what that is. All right, so we have another question from Sumit Moore. Is it okay if we can create our own data set in case we don't find one? Definitely. If you have time to create your own data set, that's awesome. And make sure when you're looking at data sets, a lot of them will have different sort of licenses on them. So just make sure that it's the right license so that you can actually use it for something like this.
And it kind of goes unsaid, but if it's coming from your employer or even your own personal data or something like that, make sure that there's no personally identifiable information and that you're not really putting stuff out into the public that should not be there.
Right. Unless it's your own, like just your own personal PII, then I guess it's okay if you really want it out there, but
it's up to you. So.
Exactly. So that's the last of the questions from the chat. We'll, keep it open for anybody else before going into our intro session. And usually we get this question, so I'm gonna answer it now. Yes, this is being recorded, and you'll be able to look back on it later.
Absolutely. Well, awesome. As Bree said, if you have any questions during the rest of this session, just ask them and we'll answer them later. Or if you want to just kind of catch any of us on Twitter or on the community Slack during the week for any thoughts, please do so as well. We're happy to support you in any way we can. But I'll turn it over to Bree and Louise now.
Awesome. Thanks.
All right. Let's get rid of Alexander and John. Okay. So for those of you still left here, somebody asked, how do I submit a question? The same way you submitted this question, you would submit a question through Twitch or YouTube, wherever you're watching. And then we'll get to it. Yep. So those of you who are left, we're going to do an intro session for ML.NET. So this will be, the very basics. What is machine learning? What is ML.NET? We'll show you how to use the tooling, how to get started with the code. And then we'll link you to the workshop if you want to do some more learning on your own. So if you want to stick around, stay on the line and we'll get started now. Unless you have anything to add, Louise.
No. I was just going to say that if you are, you are already familiar with ML.NET, feel free to drop off and start hacking. Happy hacking.
Yeah. Okay. Louise, do you want to get started and talk a little bit about what is machine learning?
Yeah, absolutely. Yeah. So when we talk about machine learning, you're often going to hear terms that are often used interchangeably. And one of the terms that you're going to hear is artificial intelligence. And artificial intelligence, you can think of it as this sort of overall umbrella that these other things fall under, right? So artificial intelligence, you can look at it as sort of tasks that a human would typically perform, except that now they're being performed by, say, an automated agent, right? And they're being done on behalf of perhaps a human, right? And an example of this would be spam filtering, right? So let's say that you have your inbox and you want to go ahead and apply rules, for example, to your email. So if this email is coming from my manager, make sure that the email address is this and then route it into a specific folder. Now you can set a rule and it's going to happen, right? Automatically, it's going to be going into a particular folder that you're routing those messages to, right? Now you can think of that as artificial intelligence because you're not actually doing that yourself. You're not going there and manually doing it. You have this sort of automated agent that's doing it, right? And the key thing to stress there is that this is rules based. So you're defining the rules for how the system behaves, right? Now, as a subset of artificial intelligence, you have machine learning, right? So that's why kind of you hear artificial intelligence, machine learning being used interchangeably, is because machine learning is a subset of that. Now, how does machine learning differ from artificial intelligence? Well, one of the ways that it differs is in the sense that instead of you providing the rules, now it's looking at historical data typically, and it's using that historical data to learn from those examples to then learn the rules. So instead of you providing the rules, now the historical data is providing enough information for the system to learn how to behave in the future based on the rules that it learns, right? And the reason that you might want to use machine learning versus artificial intelligence is, well, as you can imagine, there may be a certain point where it's not as scalable, it's not as feasible for you to capture all of the rules that may encompass the system. So that's when machine learning sort of comes in and helps you out there. And then finally, we have deep learning, which is a subset of machine learning. And essentially with deep learning, what it is, it's a basically, it's a set of algorithms. Typically, these are artificial neural networks that are used for specific purposes. Some people tend to like to think about it like if it was the brain, right? So like it was modeled similarly to the brain, because there's neurons, at least the namings. There's neurons and there's connections between them and how it behaves. But typically, these are just a subset of algorithms that perform really well. They're typically stacked algorithms, and they essentially classify inputs and produce outputs based on that. So deep learning is typically used for things like human machine translation, and they work very well for computer vision type problems. All right. So to illustrate this a little bit more, let's take a look at this example here. So you have artificial intelligence. And in artificial intelligence, if you were to ask yourself, is this a loaf of bread or not? And you might, in some cases, it actually is really hard to tell. But you can probably start to code around that, right? And to start building rules for this. So one thing that you might want to look for is, okay, well, when it's a profile image, meaning that you're looking at it from the side, does it look like a rectangle? Does it look like, are there ears? Are there sort of these different spots? Which, I mean, that could be mold as well, right? If you have moldy bread, but it may be a little bit hard to try to encompass all the rules that define what a piece of bread is and what is not. So in that case, that's when machine learning comes in. And instead of you coming in and coding all of this up, then you essentially just provide input data. And I think, give me 1 second, I think the slides haven't advanced.
Yes.
Weird. Sorry. All right. Awesome. So with machine learning, instead of you providing the rules, you just look at examples. Here's examples of bread. Here's examples of pugs. And then eventually your classifier, the algorithm that you're using to train your model, will basically learn what exactly makes up bread and what exactly makes up a pug in this case, right? So that's kind of a way to think about it. Now, what sort of problems can you solve with machine learning? Well, one of them that you can solve is finding outliers with anomaly detection. So I think that we saw this, one of the submissions, right, was detecting malware or detecting, bad actors in the network, right? So in that case, perhaps something like anomaly detection may be something that you might be interested in taking a look at, all right? Now, another type of problem that you might want to look at is predicting in numbers, such as regression and forecasting. So this might be if you're predicting sales for a given quarter or for the next year, that's when something like this might come in, right, in terms of forecasting, or even just predicting a numerical value. Let's say that, as we're going to show in an example later on, is if you're trying to predict, for example, a taxi fare, right? You're using various inputs, and based on those inputs, such as how far you traveled, how many passengers were in the car, whether you paid with a credit card, cash, however, all these different factors may affect and be able to predict what your final fare will be, right? Something else you might want to take a look at is finding relationships. Now, this one's a little bit different than a lot of them, and the reason why that is because this is an example of unsupervised machine learning. And unsupervised machine learning means that you don't necessarily know the answer ahead of time, but you're trying to find relationships and connections between your data. And an example of this might be, let's say that you have a customer database. And in your customer database, perhaps you might want to see what characteristics basically are in common between, say, your higher spenders or your higher spending customers and those that tend to not spend as much or maybe drop off somewhere in the sales funnel, right? And then based on that, you can start making some assumptions about your customers. Something else that you can do with machine learning is you can categorize items, and this one can take multiple there's multiple ways to categorize items. One is you can use binary classification, which is when you're only classifying two categories. There's multi-class, which is two or more categories, and then image classification, which is it can be two or more images that you're putting into buckets. And in this case, right, I think we saw an example where somebody wanted to basically do kind of like Google Photos, or I think OneDrive does this as well. Apple, they all kind of do it, right? They auto tag and use artificial intelligence. and machine learning to try to auto tag your images. So categorizing items would be sort of the bigger umbrella where that scenario, specifically image classification, would fall under. And then finally, and again, this is just, it's not an exhaustive list, but it gives you a very broad and idea of what things you can do with machine learning. And finally, it's just making suggestions. And a perfect example of this is essentially if you go on Amazon, on any sort of website where you, or even, for example, Netflix, right? And you're given recommendations based on your historical watching or purchasing history, what are the things that you might like? So those are the different problems you can try to solve with machine learning. And I think we saw a really nice distribution of them in the submission. So that's nice to see. So what exactly is the process of machine learning? Typically, it involves getting the data. That's sort of the first thing that you do, right? And I guess even before, there's a bit of a step before this, which kind of comes with, okay, well, what is the problem that you're trying to solve? And I think in the submissions that all you folks sort of put in, right, that's kind of step zero, if you will, right? You have this problem. There's this thing that you think, oh, can we use machine learning for this? And once you've identified that, it's like, okay, well, now that we have a problem and something that we want to solve, let's go ahead and get the data, right? And the data can be, from multiple sources. We actually, if you take a look at the README, you'll be able to see a few sources of data that we've given you that are pretty good and have very nice data sets. One of the things to keep in mind, though, is that the data may not always be in the format that you need it to. And that's where preparing the data comes in. And that may mean anywhere from, if you're working with, say, tabular data, you may have to remove nulls. Perhaps there's some columns that may not be particularly interesting for your data set. So, for example, let's say that you're trying to predict you're trying to predict something about a customer, right? Like, for example, if they're gonna basically stay with you, so retention and churn, right? So in those cases, perhaps the address, the street address of that user may or may not really impact whether that user stays with you, unless it's, for example, that they need to travel more than 50 miles to go to your store, right? Then it might make a difference, but in most cases, chances are the address may not make much of a difference. So you may choose to drop those columns, and in that case, that's part of the data preparation process. Once your data is clean, and by clean meaning that you don't have nulls, your data is not corrupted and things like that, then you go ahead and choose an algorithm and you actually train your model. And the way that you choose your algorithm, that's going to depend on what your problem is, right? So for example, if you are doing something like regression, then you probably would do something like linear regression. You may also choose to do some sort of neural network. That's also possible too. Classification, there's also neural networks that you might use. So it really comes down to what exactly is it that you are doing, or the task, kind of like we saw in the previous slide. And then based on that, you're going to see the set of algorithms that would help you train a model for that particular problem using your data. And then finally comes the evaluation step. And in the evaluation step, what you want to take a look at are the metrics. And there's tons of metrics, and there's actually no consensus per se. A lot of it depends on your data, but for each problem, whether that's regression, anomaly detection, classification, there's a set of metrics that you can take a look at to see if they're performing, if your model is performing well enough. And well enough, that's also a topic that's very subjective, and it's something that you can't really say that's what good enough means. Because, for example, if you're just trying to, say, predict a taxi fare, right, that you wouldn't say that that's necessarily a life or death decision, versus, say, when you're trying to diagnose a disease, right, that you want to make sure that it's accurate pretty much as close to 100% of the time, right? So it's going to vary what good means. And the other thing with evaluation that you have to think about, and I guess as a tip to all of you who are going to be doing this, is you may hear in the media, and you may hear sort of, buzzwords and stuff like that, like GPT-3 and these, state-of-the-art models and stuff like that. Part of the evaluation thing comes with simpler is sometimes better, right? So for example, if you're trying to do a linear regression type model, or if you're trying to solve a regression type problem, right? There is no sort of shame in starting with linear regression if it will do pretty good and solve your problem, good enough, versus, say, going out and, spinning up a VM with GPUs and like trying to train a neural network to do this. that might be a little bit of overkill. So that the evaluation step also comes in the sense that you want to make sure that is a simpler model, which is also probably easier to explain, better to use than, say, a more complex model that's going to take me longer to train, and that's not going to be as easily interpretable, and it's not going to perform in terms of my metrics, it's not going to perform that much better than the simpler model. So those are things you want to take into account when you go through the evaluate phase. And then once you're done, you go ahead and you deploy your model. And this, in the case of ML.NET, that means that you can deploy pretty much almost anywhere that ML.NET runs. So this can be a web service, this can be a desktop application, this can be a static site, kind of like using Blazor WebAssembly, right? So there's many different targets that you can deploy to with .NET, and in a lot of those deployment targets that .NET runs on, you can essentially deploy ML.NET models. And then comes the inferencing part, which that's just using your model that's deployed wherever it is that that deployment target is, and making predictions based on that. Now, at some point, you see here that there's a loop between the prepare, train, and evaluate, and that's because in the event that in your evaluation phase, your perhaps your model's not performing as well as you think it should, then in that case, you may have to go back to one of the previous steps, perhaps choose a different algorithm that may work better for your data, or perhaps you don't have enough data, so you may go back to collecting the data and preparing your data and doing this, right? And it's all iterative, because chances are that whatever you're doing between, basically if you're getting data, especially data that may be impacted by seasonality, right? So your data from a year ago and the customers that you were working with a year ago may not be the same customers or the same products or the same things that you're working with in the next year, right? So your data is going to change, and as a result, your model will too. So you're going to have to retrain and prepare the data and do all these different steps, over and over again and iteratively. Okay, so that's pretty much the workflow. Now, in terms of the ML landscape, there's a lot of tools that you can use. So some of you may or may not be familiar with these. One of them is scikit-learn, which is a Python-based tool, and that one allows you to train classical machine learning models. The next, and by classical machine learning, meaning doing linear regression, logistic regression, like naive Bayes, and all that sorts of stuff. If you are looking to do some more deep learning type work, you may consider TensorFlow, and you may consider PyTorch, right? And these two tend to be the more popular sort of frameworks out there for doing deep learning. As sort of a top or higher level API on top of TensorFlow, one of the things that you can use is Keras, right? And TensorFlow in this case may be the backend it's the backend that's driving Keras, but again, Keras allows you to just in a simpler way define and express how your neural networks and how your models or how the structure of your algorithms will look like, right? And then sort of as a layer under that is, and it goes across all of these, is Onyx. And Onyx is sort of this interoperability format. It's a serialization format for saving your models. And with the freedom that this gives you is that, let's say that you trained a model in scikit-learn, right? But let's say that you are going to consume it somewhere else, say in ML.NET, perhaps PyTorch, somewhere else, in some other framework, you're going to perform the inferencing. So training happens on one framework, inferencing happens for whatever reason on another. You can leverage Onyx to convert your model from that one framework that you trained in, and then consume it and use it to make predictions using this other framework, right? So it's really nice because it gives you that sort of interoperability layer. Now, if we were to look at what exactly is it that are the offerings at Microsoft, right? One of them is Azure Cognitive Services. And what Azure Cognitive Services allows you to do is it allows you to essentially go ahead and make predictions just using a REST API. Now, one of the things here is that with Azure Cognitive Services, it's a bit of a black box in the sense that you don't necessarily know which models are being used. You're just using it for inferencing, right? So in very few cases, you're able to train your own model using your own data, but in a lot of cases, you're just using a built-in model that's out of the box. And this is really easy because all you have to do is you have to provide your data, and you're ready to start making predictions across these various types of problems like image classification, object detection, and so on and so forth, and text analytics. Now, if you would like a little bit more control in terms of how you train your data and the algorithms that you use and how you deploy your model, then something you might consider is Azure Machine Learning. Now, Azure Machine Learning, you can think of it as this product that provides the glue for you. So at each step of the process, there are things that you need to do, such as basically putting your data somewhere so that it can be read and ingested into the algorithm that you're trying to train. And then eventually, once you train your model, you perhaps might want to register it somewhere so that you can save it and then deploy it to some sort of endpoint, right? Azure Machine Learning also provides you with inferencing services. So it's fairly easy to deploy it as a web service. One thing to note is that Azure Machine Learning tends to be more Python and R based, right? So that's not a bad thing per se, but that's just something that is very traditional, a traditional stack or a traditional set of languages that are used in machine learning, right? And then for inferencing purposes, you have WinML. Now, this one is sort of its own little category because you can't train models with WinML, but what you can do is you can inference existing models, and in cases where in some cases you can even leverage GPUs and you can provide hardware acceleration for making predictions on Windows PCs. Now, so WinML is strictly for Windows, right? So if you're doing inferencing on Windows, that's kind of something that you might want to take a look at. And one of the nice things is it's interoperable with Onyx. So again, going back to whether that's scikit-learn, PyTorch, TensorFlow, whatever, right? You can convert your model to Onyx and you can use it to inference in WinML. And then last but not least is ML.NET. So ML.NET, which is what we're all here to kind of talk about and kind of hack on, it's this open source cross-platform framework, right? And it's built for .NET developers. And Bree will kind of go into these a little bit later. But essentially, in this case, you can use your own data, right? You can choose your own algorithms. You can go ahead and essentially do that, whether that's on-prem or in the cloud. ML.NET can kind of like work across all these services. And one of the nice things is that you can actually interop. Again, using Onyx, you can interop across these other services like Azure Cognitive Service, Azure Machine Learning, WinML, etc. So with that, Bree, you want to talk about ML.NET?
Of course, yeah. So like Louis said, ML.NET is an open source and cross-platform machine learning framework for .NET. A little bit of the history. In 2002, Microsoft Research actually began this text mining search and navigation project so that internal developers at Microsoft could add custom machine learning to Microsoft products and technologies. In 2011, the library was renamed to the Learning Code, or TLC, and since then it's been widely used within Microsoft for internal products. So things like Windows Hello, Bing Ads, and the list goes on. And then in 2018, TLC was actually made open source, cross-platform, and it was released as ML.NET in that first public preview of Build of 2018. And then in the next year at Build, it was the GA release was at Build. And then, of course, this year in 2020, we had our first virtual ML.NET conference and then our first virtual hackathon. So Louis already mentioned this, but ML.NET runs essentially anywhere that .NET runs, whether that's on-prem or on any cloud like Azure. You can train and consume custom models. And then, of course, on Windows, Linux, and Mac. So what we emphasize for ML.NET is we're not trying to pull data scientists away from Python or R. It is built for .NET developers so that you can stay in the .NET ecosystem to build custom machine learning models and add them to your .NET applications. And specifically, we don't require that you have an intensive data science or machine learning background in order to do this. And the way that we enable you to do this is through something we call AutoML, or that is called AutoML, I guess I should say. AutoML is short for automated machine learning. And as Louis showed you in the workflow before, it's a very iterative process of prepping your data, training your model, evaluating. So it's kind of this cycle. What AutoML does is it automates this cycle, and it will, you'll choose your scenario, you'll input in your data, and then AutoML will go through different iterations of models. So it'll try out different algorithms, different algorithm options in the given amount of time, and then it will get your top model for you based on the data and scenario that you have. So what that looks like with ML.NET is you've got the ML.NET API, which is a set Microsoft.ML package, again, cross-platform. And then on top of that, we've got the AutoML.NET API. So this is the local AutoML where you can locally train models with AutoML. And then on top of that, we have our tooling. So we have Model Builder, which right now is just offered in Visual Studio. It's just a user interface on top of AutoML. And then we've also got the ML.NET CLI, which is cross-platform, which again utilizes AutoML. And we'll show these off in a little bit in some demos. What can you do with ML.NET? So all the classical machine learning scenarios you see on the left, you can actually train custom models for. And Louise gave examples of each of these, so I won't go through them. But then on the right side, you've got some deep learning or custom vision scenarios as well. So for image classification, you can train custom image classification models locally with a process called transfer learning. For both image classification and object detection, you can also consume pre-trained models. That's both TensorFlow and Onyx models. So ML.NET is really extensible. And I'll show you in this next slide. When would you want to use ML.NET? Well, if you want to stay in the .NET ecosystem for machine learning, that's the biggest one right there. If you want, that could be whether you want to train a custom model in .NET or if you want to consume a pre-trained model. So this could be, for instance, if you're working with the data science team who prefer to work in Python. So let's say they use TensorFlow or PyTorch to train a model, and then they can convert that to Onyx, and then you could actually consume that Onyx model with ML.NET in your .NET application. So from there, unless Louise, you have anything to add, I'm going to jump into some demos.
Yeah, no, let's go.
Awesome. So the first one I want to show off, I'm going to show off Model Builder here. And let me pull that up. So what I have right now is, this is just VS 2019, the latest version of it. I created a .NET Core console application that just prints out hello world to the console. What I'm going to do is I'm going to right click on my project and add machine learning. And this opens up the Model Builder UI that I talked about earlier. And we'll give it a second to come up. I'm, sharing my screen in my video. My computer is not very happy right now. And Visual Studio. I have 2 instances of Visual Studio open. So,
while that's coming up, we see that we have some questions here, but we'll get to those at the end. So hang tight, and we'll try to get to all of them at the end.
Perfect. So what you see here, this is the first page where you can select your scenario in Model Builder. These first ones are ones that are backed by AutoML right now, so you can train with your own data. And there's these little tags that say whether you can train them locally or in Azure or both. And then we have these limited scenarios, which are not yet supported by AutoML, but we didn't want to leave you hanging since you can still create anomaly detection, forecasting, and clustering models with ML.NET. These will just link you to tutorials and samples. Eventually, we do plan to add all ML.NET scenarios to AutoML and to our tooling for both local and Azure. So in this case, I want to do object detection. What I really want to do is create an object detection model that will detect if there's where a stop sign is or stop signs are in an image. And this, you could see how this could be really a really practical example for self-driving cars. Right now we only offer training in Azure. We're working to add local as well. So what I would do is set up a workspace, and I can do all this right in the UI in Visual Studio in Model Builder. So this dialog comes up where you can select your VS subscription, and then you can either create a new workspace or select an existing Azure Machine Learning Workspace. In this case, I have one set up already. But if you hit new, you don't have to go out to the web to do that. You can do it right within the dialog here. Same for compute. You can create a new one or select an existing. I'm going to select an existing one, and then I'll leave the experiment name as the default and hit create. As soon as I hit create, it's actually creating this workspace for me where my experiment will run once I start training. So I'll go on to the data step. And so here, the data is supposed to be in a very specific format. This opened in my other screen here. You can see it's in this kind of where it will have the tags, what the name of the tag is. It'll have the positioning of the tag, the coordinates of the tags. So we recommend using a tool called VOT, which we put right here, our visual object tagging tool. And I'll show you what that looks like here. So for VOT, you'll put in all your images that you want to tag, and then you will go through and label them. So for instance, you can see I drew a bounding box around here, and I actually labeled it stop sign, and I did that for each image. And then I would save that and export a JSON, which I could then put right into Model Builder. So of course, I've already done this process, and let me just find it. Here we go. So once I select this image, it's this JSON, and which is linked to all the different images that I have and all the different coordinates. It's actually going to give me a data preview. So we'll let that run. So you can see here, it takes the top 4 images and shows where those bounding boxes are. If I had another label, say, I don't know, another sort of like yield sign, it would have that as well in the list of objects. But in this case, I'm just detecting stop signs. So then in the train step, what I would do is I would hit start training. And this would send all my data up to Azure, and it would train with Azure ML. And then once it's done training, it sends down both an Onyx model and the trained ML.NET model. So of course, I will not go through that whole process right here. But if we take a look here, so using the same data set that I mentioned before, I went ahead and trained earlier. It took about 769 seconds. I don't know how many minutes that is. Math is hard. So we got one model back with an accuracy of 91%. And then in the evaluate screen, you can actually try it out in the UI before adding any code to your solution in case you wanted to go back and retrain. So in this case, I uploaded this image and it detected a stop sign here, and it's about 99% confident that this right here is a stop sign. I'm going to try it with another one and with 2 stop signs in the same image. So we'll give it a little bit of time. And you can see how important it would be for a model like this to have a very high accuracy when it comes to self-driving cars. Being able to see stop signs or places to stop, or even just obstacles in the way and stopping quickly, is very important.
That being said, we wouldn't want to deploy this into our Teslas, right?
This particular model, I mean, yeah, you could try, but actually, no, don't. Then I'm going to be liable. Do not use this model in your Tesla. And we'll give it a second. Again, all my resources are being used up right now on my computer. So, okay, so you can see here that it detected 2 stop signs. The top one, it said, yeah, we're 99% sure that this is a stop sign right here. The other one was 87%, so it was a little bit less confident in that one. So you can see that there's this score threshold here. And as I start to decrease the threshold, it starts detecting maybe objects that might not be stop signs. So in this case, if I put the threshold below 78%, it's going to show any objects it detects with at least 78% confidence. So of course, then I would actually want to keep it above that threshold, since it seems to be doing a pretty great job with these 2 right here. And then, so the next step here would be to consume the model if I'm happy with it, or, deploy and consume. So in this case, when you hit add to solution, you'll see here, I don't know why it brought me back to evaluate, but you can see here that it added these 2 projects to my solution. It's a console application and then the class library. So the console application, it has the model. For local scenarios, you'll have the actual training pipeline, and it'll show the algorithm that it chose, the data transformations, and so on. We don't yet have that capability for models trained in Azure. Another thing that this console app has is and let me zoom in here, is a sample of how to actually consume the model. So in this case, you would just create a new model input here. And, this is my test image. So indicate where your test image is. And then you would call this predict function from the consume model class on our sample data. And then it would actually give you where, any predictions, any objects that it finds. And to show you what these are, so this is the Onyx model right here that gets passed back from Azure, as well as the serialized zip file, that's your ML.NET model. And then the model input here is going to be the label and where your image source is. And then the output is going to give you, this one's a little bit more complicated because it's object detection, but it'll have your labels, where the bounding boxes are, and what the confidence scores are. And then this consume model class will have everything for loading the model, as well as creating the prediction engine and predicting, actually making the prediction with the model. So all you would have to do in this case to get it running in the console application, at least, would be to copy paste this code. The reference to the class library is already added. So you just copy paste this code into the console application and run it. It isn't very visual with object detection in the console, so I won't go through that. But you can see what that looks like here and how it was evaluated in the UI. The other example I want to go through, so this is with Model Builder. For those folks who don't use Windows or maybe don't use Visual Studio, we've got the ML.NET CLI. So I'm pulling up my command prompt here. So let me go to my desktop. And so the ML.NET CLI.
Just a little bit.
Sorry, what did you say?
Can you zoom in
Yes,
just a
I
little
can
bit?
do that. I don't know how to make the text bigger. I don't think so. I'm just going to zoom in this way. Is that better?
Yeah.
Okay, cool.
Much better.
So the ML.NET CLI is just a .NET global tool. So you can do .NET install MLNet. And you can see here right now we support classification, regression, recommendation, and image classification. And this is all right now just local training with that local AutoML. So let's take a look at classification and what that section looks like. So you can see all the different options that you have here. All that's required is a data set and to choose your label column or the column that you want to predict. All of these are just other options that you have. So let's try it out. I have this data set, and actually let me show you the data set before we train so you get a better idea of what we're doing here. Okay, so these are Yelp comments left for restaurants, and then whether those comments are positive or negative. So this is known as sentiment analysis. So you can see, wow, love this place is going to be negative. Crust is not good. Well, that's sorry. Wow, love this place is positive, and crust is not good is negative. And so I forget how many. I think there's 1,000 or so of these in here. And I'm going to use this to train a sentiment analysis model with the ML.NET CLI. So to do that, I've got MLNet. We're going to choose the classification task. My data set is going to be Yelp comments.txt. My label column is going to be sentiment because I want to predict what the sentiment is, not what the comment is based on a sentiment. And then I'm actually going to give it a train time because I think the default is 60 seconds, and I don't want it to run for 60 seconds. Let's do 30 seconds instead and see if it will come up with a model. And hopefully I typed that all out correctly. So you can see here it's starting to train, and it actually has a countdown here. So again, this is using that AutoML.NET API, or the automated machine learning, to iterate through different models in the time that I give it. So as it starts to find models per iteration, they should show up here. Hopefully in the amount of time I gave it, it will find at least one. It might not, again, because I'm using my computer for so many things, but all right. So yeah, it looks like we did get one. If I'd given it more time and had not been sharing my screen and my video and everything, it probably would have come up with quite a few more models. Usually in 30 seconds with this data set, I get 4 or 5. But in this case, we end up with this trainer. So at the end, it gives you a summary of the task that you chose, what was your data set, what was the label column you had, how long it actually took, and then how many models it explored, and then usually the top 5 models that it explored. So what it's doing now is it's actually generating the code similar to how Model Builder did for consumption, and then also that console app. So let me see if I can go find that here. So here's that sample classification project that I created, or solution, I guess I should say. And I'm probably going to regret trying to open this up here. We'll see how long it takes. I do have VS Code as well that I guess I could show, but let's see how this goes. But those are the same projects, and let me zoom in here, that I showed before, where you've got your console application and your class library that has the actual model. So I'll let it load up in VS here. I want to show you the actual, because this was a local scenario, it actually gave us the training pipeline. And so I want to kind of dig into the training pipeline to show you what that code looks like. And it's loading. Anything to add while VS is loading up, Louise?
Yeah, no, I guess the only other thing that I would add is in this case, you're just running it once, but the CLI is actually a really good tool if you want to automate this and your training processes are automated. It's a really great way to do that, right? So on top of using AutoML, which automates a lot of it, you can also automate the running of the training process with the ML.NET CLI. Right.
Yep. That's a great point. All right. I've got it open on my other screen, but it is frozen in place. Yeah, we'll just give it a second. Maybe I should close my other 2 instances of Visual Studio. That might help. Okay, here we go. Okay, so here's that console app and model. So you can see what the model input is actually going to look like for this scenario. Maybe. So in this case, you've actually got the comment and the sentiment, which is used for training. And then the model output that you'll get is the label, so whether it's positive or negative, and then the score, so how positive or how negative it is. already showed that one. Consume model is also, it's very similar, or I think the same actually, where you, and we can go over this in a second since we want to go through the code anyways. But let's take a look at this modelbuilder.cs. And this is going to be the training pipeline. So hopefully that will be zoomed in enough. You can see here that it takes the file path of my training data set, which was that Yelp comments.txt. It's going to also have the model file here. And then the first thing you'll do when starting with code first for ML.NET is create an ML context. This can be the starting point for all ML.NET operations. It's often compared to DB context and entity framework, so you'll have a catalog of things that you can do with ML context. So then what we do is we're going to load in our training data, and we're going to load it into an iData view. This is the data format for ML.NET. It's a way of viewing tabular data. It's very flexible and efficient. And you can load from a text file or an enumerable. You can load from pretty much any database that .NET supports. Anything I'm missing there about iData view?
No, I think you covered it most of it, yep.
So in this case, I am loading from a text file, and we're using that model input schema of comment and sentiment. And I gave it the path that we defined earlier. In this case, it does have a header. It's separated by tabs and a few other things that the only thing that's really required is the path, and then making sure that you define if it has a header or what the separator character is if it's not the default, which is tab and then has header as false, so are the defaults. So then you want to start building your training pipeline. So let's go down to this build training pipeline method. In this case, so we're going to do the data processing first. And as Louise mentioned in the model lifecycle graph that we had, the data that you have is not ready to be input into or given to an algorithm yet. Algorithms only see numbers, so or numeric vectors. So especially all the text that we have, the comment text, we need to make sure that we convert it into a format that's appropriate for the algorithm. So in this case, we have quite a bit of data transformations. We have map value to key, featureized text, copy columns, normalize min max. So these were all chosen by AutoML based on my data set and my scenario. So then after setting up all the data transformations, we want to actually choose what our algorithm is. So in this case, we've got, I don't know why it does multi-class and then binary. Do you know why it does that, Louise?
Sorry, where is that?
So in this case, it has multi-class and then binary classification.
Actually, no, that's a really good question. TBD.
Yeah, TBD. It's something that AutoML did. I'll have to go back and look why it did that, but it's classification. So it chose these algorithms and algorithm options. So this number of iterations is a good one, where it actually would tune that what we call hyper parameter. In this case, number passed through the training data set, and you can change this number and see how it affects the results. But in the one iteration that my AutoML did to determine this was the best one. Obviously, if it had more time to train, it might, try out different number of iterations and see which one might be better. So then the data transformations are appended, the trainer here that we chose is appended to the data process pipeline to create the whole training pipeline. So we'll come back up here to our next step, which is actually training the model. So up until now, all you've done is set up what's going to happen when you train the model. So nothing's actually happened yet. So we'll go down to the train model method, and you can see here that this fit method, that's when training actually happens. So you get your training pipeline and you're fitting it with your training data, which is in that iData view. And what you'll get back is this iTransformer object that is your trained model. So in this case, we're returning the model up to the top here. And then we want to evaluate the quality of the model. So we'll go down to evaluate. Went past that. So in this case, it's because we didn't provide it a test data set, which you can actually do in the CLI, but you can't yet do in Model Builder. That's something that's coming up. It does something called cross-validation with the single data set. It actually says it in the comments here. Awesome. So that's used to get the model's accuracy metrics. And you can see here that it does this cross-validate. You can define the number of folds that it does, and just giving it a few different inputs here. And then actually this will print out those metrics to wherever this prints out, which is, where is this? Down here. Yeah, so out to the console. And you can see it will print out the macro accuracy, micro accuracy, log loss. Usually for classification tasks, the accuracy is going to be what you look at. So after you're done evaluating your model, let me see what the next, I think it's save. Yeah, so the next thing this does is actually save the model. And so if we go down to save here, you use that ML context.model.save, and then you can save your model to some sort of, and you can define the folder here. And in this case, it was saved right here in the class library as this serialize it file mlmodel.zip. So that's training the model. So now when you want, what do you do when you actually want to use the model or consume the model? And I'm kind of skipping the deploying step, just going to the consuming step. Because that's what's produced here for us. We'll go to this consume model.cs. If you're using tooling, you can simply just call the predict function here. But if you're doing it, code-wise, this is what you would do. So make sure you have that path to your mlmodel.zip. You'll also create a prediction engine. What a prediction engine is, it's a convenience API for making single predictions. So here you can see, let me see here, I haven't looked at this code in a while. To get the result. So essentially you'll have an input. Let me see here. So you'll have your model input, which is defined here. So essentially you'd have something that would have a comment, and you would set the comment for that input. And then you would use the prediction engine and the predict function there to make a prediction on your input. And then that result would be returned, and that would be this model output. And so what you would get based on the input that you give it is an output with a predicted label and a float array of scores. And here's actually that create prediction engine function up there. So again, you create your new ML context, you would load your model and then actually create that prediction engine, and then you can use the prediction engine predict function on your model input. Anything I missed there, Louise?
No, nothing, but a quick answer to your previous question, why a multi-class classifier uses a binary. It's because it's actually training a binary classifier on each of the classes. So it chose to use, I think, what was it? It was the one versus all algorithm actually uses a binary classifier. Yeah, there you go. So the one versus all is a multi-class classification algorithm, but in itself uses a binary classifier for each of the classes. In this case, the binary classifier that it used was the average percentile.
Okay.
So that's why.
Interesting. Okay. Good to know.
If you have any questions, check the docs, reference the docs.
Should have done that first, huh? Okay, cool. So that's a quick run through through the code here. We have a ton of different samples, and I'll actually pull that up now. Let me pull that up. I want to show you all our code samples here because it will show you step by step, essentially the same thing that I showed you. So that's GitHub machine learning samples. And we have a resources slide at the end. I believe we linked to this. So here you can see we have a ton of different examples, and each one, here's that sentiment analysis example. A few of them have F# equivalents as well. I'll just show the C# one. And again, it's that same thing that I showed you with the iData view. It's always going to be essentially the same. You create your ML context, you load your data, you set up your pipeline, you train, you evaluate, you save, and you consume with the ML.NET API. But yeah, so that's what I've got. Now, Louise, you have a demo as well, right?
I do. So let me switch screens here. All right, there we go. So the example that I have here is one that kind of showcases the interoperability and how you might use other tools and other frameworks to perhaps train your models, or even take existing models that were trained elsewhere or by someone else. And then you can just consume them inside of ML.NET, right? So in this case, what I have here, and I'll show you the app first to show you what it does, and then we're going to kind of walk through the code. In this case, I have a WPF, so a desktop application. And what I'm doing is I am trying to predict taxi fares. So let me actually zoom in a little bit here. I know that it's a little bit small. And there's a few inputs that I'm going to be using. Ultimately, what I want to see is I want to be able to predict the fare, right? So in here, my vendor ID, this means something in the data set, right? If the rate code, this also has a meaning. There's only one passenger. Trip seconds, again, let's do 1280. Trips distance, let's do 3.1. Whatever kilometers, miles, whatever it is that you want this in. And then our payment type, let's say that we pay with a card. Now, when we click predict fare, what that's going to do is it's going to take all of these inputs here, right? And it's using a model in this case, right, to try to predict what the fare will be based on these inputs, right? So now that you get a general sense of what exactly is it that this application is doing, let's go ahead and take a look at the code, right? So when you're consuming a model, there's actually different ways that you might want to go about this. Personally, I think that this is actually a pretty clean way to do that in. And the way that we start off with, and to give you a little bit of background, we trained this model in Azure Machine Learning, right? So this was trained using Python and the tooling that Azure Machine Learning provides. But one of the things that you may notice here is that the model itself is an Onyx model, right? So as we mentioned before, Onyx, or the Open Neural Network Exchange, that's kind of the actual name for it. It's this format that allows you to serialize your model in this format that is interoperable and usable across different frameworks and different platforms. And in this case, we're going to take this model that was trained in Azure Machine Learning, converted it to Onyx, and now we're just going to consume it inside of ML.NET. Now, you can imagine in the real world how this might work is you have a data science team where your peers are data scientists. They're working with Python and its traditional stack of data science and machine learning tools, and they just give you a model and they tell you, here, put this into production, right? So this is kind of that process here. And what we want to do here is we start off with this console application. And what this console application is going to do is it's going to essentially take the Onyx model and build an inferencing pipeline, right? Or a prediction pipeline. So similar to kind of what Bree showed off, where we created a data prep and a training pipeline. In this case, we're going to create a prediction or inferencing pipeline. So if you're kind of getting the sense of it now in terms of ML.NET, is everything kind of works through pipelines, right? So in this case, we have our model path, right, which is the name of the file, our Onyx file. And then what we initialize here is this thing called Azure ML Model Loader. Now, in this case, it's a convenience thing that I built. It's actually a shared library that I created to sort of interact with this model and perform some of the basic functionality that typically is required by ML.NET in order to create your pipeline. So I then use this convenience sort of a library that I created, Azure ML Model Loader, and then I execute this function called get pipeline. Now, what get pipeline will do is, again, as you may notice here, there's that ML context, right? So that ML context is going to be what we are using throughout all of our operations in ML.NET. So in this case, first we check, of course, that model path. We do some validations. Now, we have some input columns here that are vendor ID, rate code, passenger count, trip time in seconds, trip distance, payment type. One thing that I actually didn't show here, and see if I can sort of pull that up real quick here, is how do I even know these things, right? So here I'm telling you what these input columns are, but I'm not exactly telling you how I got them. So in this case, I'm going to be using a tool called Netron to inspect our model. And what Netron does, it provides you with the graph of your model. Now, there's no in between here. Let me see. Oh, there we go. Okay, so that's a little bit better. So there's no in between, but you'll see here that the inputs here, and you'll notice that it goes top down and sort of like a graph that flows in one direction. And these are our inputs, and you'll see there's rate code, passenger count, payment type, vendor ID, right? So for ease of use here, you can click on any of these. And what you're going to get here on the right-hand side is this sort of panel and metadata information about the model. You're going to see that it's using Onyx v6, the version 6 of the Onyx format. It's going to give you a little bit of metadata description. Again, this varies by model, but some of the things that you're going to want to take a look at here are the inputs, right? And here you'll see that the inputs in this case are the columns. These are the names of them. And then more importantly, these are the types. So you'll see that the vendor ID is a string, this is an integer, this trip distance is a flow, and the payment type is a string, right? So, and not only does it give you the type, but also gives you some dimensions. Typically, when you're working with Onyx models, or in a lot of times with machine learning, you're typically working with arrays, matrices, vectors, right? So in this case, you're looking at something that contains only one value, right? So there can be only one value, right? So that's how you would inspect that. In this case, I already had it installed, but there's also an online version of this app that you can use, so you don't have to install anything, right? And that's kind of how you get that information about what exactly is coming in. And then at the same time, let me just kind of, I glazed over that. Here you have your variable out, and that's going to be your output, right? So now that we know the names, the types, and the dimensions of our model, now we just express that in code. In this case, our input columns. Our input columns are here, which is just something that we took from Netron. And our output columns is this one here, variable out1. Okay. Now here, we're going to go ahead and create our pipeline. So again, using the ML context transforms, we use the apply Onyx model transform. And we just need to provide it the name of the output columns, the name of the input columns, and the model path, which, as you may recall, it's something that we pass into this function that we defined in our console application, right? And then all we're going to do is we're going to load from enumerable. So this is something that's key to creating your pipelines, is you need to provide information about your schema to your pipeline, right? And the way that you do that is by telling it the type of data that it should expect as input, okay? Now, in this case, because we're not training, we don't actually have to provide it with actual data. We can just create an iData view, an empty iData view. And that's what this ML data load from enumerable is doing, of auto Azure ML Onyx input. Now, what exactly is that, you might ask yourself? Well, similar to kind of what you saw with Bree earlier in the auto-generated code, where you have model input and model output, that's exactly what this is, right? And in this case, we've just used a few things here. Now, one of the things that you'll notice here is we're using these attributes that are specific to ML.NET. And what these attributes allow you to do is they allow you a way to add more metadata to your your data schema, right? So in this case, you remember that the name of our column that's expected by Onyx is vendor_ID. But that may not be exactly the .NET-like way of doing things, right? Perhaps the casing and the naming conventions may be a little bit different. So in that case, we can still use our standard naming conventions that we use in .NET, but by giving a column name, when the model is actually processing data and looking at the data, it's going to reference it internally as this other name that we're telling it, right? So column name is one of the things that you might want to use when you want to map columns that may have either different names, or you may want to reference them differently. And then this other one, which is the Onyx map type, which is actually really useful. Now, what this is doing is, instead of you going and writing your own custom casting function, or your custom casting functionality for this, you can just tell it, hey, the type that Onyx expects is an int64 for this particular column, right? However, ML.NET only works on single data types, or floats, right? Or floating point values. So what we're doing here is we're taking this original int64 value and casting it, or mapping it back and forth between ML.NET and Onyx to this particular type. And we do that for all the types that it requires. In this case, if we recall, trip distance was a float. Therefore, we don't need to do that conversion, right? And then we kind of do the same thing with variable out. In this case, we're gonna get a float array, in this case, as output, right? So let's go back here. Sorry, one quick second. So model loader. Okay, so once you've created your empty iData view, you just fit your pipeline so that you're able to then get something that you can then use for making predictions, right? Now, the thing is, though, if we were going to just score here and we were going to use this already to make predictions and to inference, that would be okay, and we can just use it one time. The problem is you're probably going to want to load this in some other application. And that's exactly what we're doing, because if you're looking at this here, this is actually a console app where we're using it to create our pipeline. we're not actually doing any scoring here. We're just preparing the pipeline. So in order to do that, we just save our pipeline. And very similar to how it was sort of shown off in the demos that Bree showed, all we're doing is we're telling it ML context model save. We're providing it with the pipeline. In this case, it's this pipeline here. And we're telling it save it to this particular directory. OK. So in this case, you're not going to be able to see it here because the way that folder structures work, this is actually the Azure ML MLNet model.zip file. It's actually just being stored inside of my build output directory. OK, so you're not going to necessarily see it here, but it's inside of the build output directory. OK, cool. So now I've used this console application to create an ML.NET pipeline. How do I consume it? And that's kind of where this piece comes in here, our WPF application. So if we go to the code behind of our application here, you're going to see that whenever our main window initializes, we're going to do a few things. Again, we're going to use this convenience sort of object that we're creating here, this Azure ML model loader. And then we're going to tell it get save model. And there's nothing special going on here. We're just essentially looking in our, we're looking inside of our build output directory, and we're using that ML context model load. In this case, we're just providing the name where that file is saved. And then it's just returning that model to us, right? And in this case, it's an iTransformer. Once we have our model loaded, then we just go ahead and create a prediction engine. In this case, we, again, use a convenience function here, get prediction engine. We pass in our model, and then it gives us a prediction engine that takes in as input an Azure ML Onyx input, and output, it's an Azure ML Onyx output. Okay, so again, nothing special. It's all the same stuff that you would do as if you were doing or using traditional ML.NET models. ML.NET models. And then finally, it's what happens or what is the behavior once we click that button that tells it to predict a fare. What we do is we take input and we bind to the specific form inputs. And then we just create a new type or a new instance of this Azure ML Onyx input. Once that's created, there is the place where we're going to be outputting the predicted fare out to the text that is generated or that's predicted, and we just call prediction engine predict. And then in this case, we're accessing the predicted fare property. Now, what is that, you might ask? If you remember our output, we called it predicted fare, but Onyx uses the name variable out1. So when we're addressing that particular value in .NET, we're going to call it predicted fare, which is a little bit more descriptive than what's it called, than variable out1, right? And then because there should be only one value, although we're getting back a float array, there really is only one value. So we just call the first, extract the first value, and that's kind of what we're going to be outputting back. So essentially here, that's all you need to do. And as you'll see, there's not much more that's involved than if you were doing, or if you were using an ML.NET model. In fact, there's actually nothing at all, right? All you're doing is you're creating your pipeline. In this case, it's just for inferencing. You're saving your pipeline, and then you're loading it inside of another application and using a prediction engine to make your individual or single prediction. So with that, I think we can kind of go back and try to wrap stuff up and then get to questions.
Yeah, so here's a little bit of a roadmap. So we just released a new version of Model Builder. I'm still working on a blog post for it, but it is in the Visual Studio Marketplace. So Model Builder now has some more advanced data loading options. We have some Azure ML dataset support coming up, as well as making sure that all Azure supported scenarios are in Model Builder and tooling. We are adding what we call reentrancy or reopening state in Model Builder, as well as we're planning on open sourcing our tooling. We are hoping to get to it before the hackathon so that people could work on the tooling. We weren't quite able to do that, but we still are planning to open source Model Builder and the CLI. But yeah, so ongoing MLOps integration, that's something we're currently working on and investigating, as well as model explainability, and making sure that all, and I kind of mentioned this before, but adding all ML.NET scenarios to AutoML, both local and Azure, and to our tooling. And then also just making sure that ML.NET runs anywhere that .NET runs. So that would include Blazor WebAssembly, mobile, IoT, and as new versions of .NET come out, just making sure that ML.NET is compatible. And, you know, you can have a seamless experience with it. And, oh my gosh, some resources. I've added, Luis and I our Twitter handles on there. You're totally welcome to reach out on Twitter. And then just a bunch of resources. So we're probably past the get started. There is a very simple sentiment analysis with model builder tutorial here. This is more of our landing page. We have all of our samples here that I showed before on our GitHub samples repo. We've got our docs, which Louise has written a ton of, and they are awesome. Some ML.NET videos here. Our GitHub repo here where you can request features, ask questions, or contribute. And then this is the workshop that we had talked about. If you want to continue on past kind of this intro that we just did, I would recommend doing the workshop. It's a self-guided type thing, and it digs a lot deeper into all aspects of ML.NET. But yeah, so from there, let's take it into Q&A. I will add Alexander back and John to the stream. I'll leave the resources on here as we answer questions. Welcome back.
Cool. Thank you, guys. Awesome. Glad you went through all of that. A lot of good content. So we got a lot of good questions in the chat when you were presenting.
Yeah, I saw that.
Yeah, a couple of them I think are like contextual when you were describing things, so it may be difficult to answer afterwards. But
let's see. I've gotten here. So we talked about this before, but energetic envelope said Microsoft also uses the term cognitive services. Is that Microsoft AI solutions? So Louise went over kind of the machine learning landscape at Microsoft. So you can go back through that slide to kind of see, but cognitive services tends to be pre-trained models that you can call, and it's, as a service. So you pay per inference. There also is custom vision where you can train custom image classification and object detection models. Those you can actually export to Onyx. So Louise actually just wrote a doc about how to train with custom vision and object detection model, export that to Onyx, and then consume with ML.NET. But yeah, then let's see what else we got here.
There's a couple of good ones.
Yeah, so I see that ML.NET does support custom models. Can you create custom networks with it? I couldn't find that documentation. I assume that means custom neural networks, unless...
Most likely, yes. And I think on that point, though, I mean, so I guess ML.NET doesn't support out of the box doing that right now. It is transfer learning, which is retraining certain parts of the network, but not actually building your own layers. However, I know that the SciSharp team, they, I think, just released Keras.net, right? Or at least had pre-released at least, where they're using kind of similar as Keras in Python, but for .NET to build your own networks and your own layers. That's really cool. I haven't done it yet, but I'm really excited about that for sure.
Yeah, and we're actually working with the SciSharp team to make sure that it integrates flawlessly with ML.NET. So this is something they just released, I think, last week. So I haven't been able to play around with it yet. But it was a request we've been hearing a lot about building custom neural networks or having a Keras-like API. So here we have Keras.net, which is awesome.
Yeah, it's gonna be fun.
All right, so here we've got for image data, what formats can be input into the models? I assume they mean for like
JPEGs. PNG,
yeah.
I think, yeah.
I believe it's for model builder. I believe it's JPEG, PNG, and actually I'll have to go back and look. Isn't it? I think it's in our docs though, right, Louise?
Yeah, I'm actually pasting the link.
John, I know you're still there, but I'm sorry you get the .NET icon.
There we go.
You have to move around here.
Yeah.
And did you post it in the chat here?
I posted into the chat,
How-to guides. Okay, load.
So the one that might be missing there is the one that we went over, which is bot, right? So for object detection, we recommend at the moment using bot, BOTT. And that's an external tool that, again, as Bree sort of suggested, it creates a JSON file that provides not only the link to or where the path to your file, but also provides information about where the bounding boxes are for the objects that you have tagged, right? So So that's probably what you want to go with. That being said, if there are folks in the chat who have ideas in terms of the different ways that they tag their data, we'd love to hear from you as well.
Definitely. Yeah, so we posted that chat or the link in the chat there. So the next one, where should I put the cross-validation code before metrics?
I think it was a contextual one when you were showing a piece of code, so that may be difficult to answer right now, but learn.net definitely clarify in the chat if you have a specific question there.
And is there anything else that you all want to say about cross-validation in general?
Yeah, I think that this question was in regards to the step 4 in the workshop. So you can take a look at that, and if it's not clear enough, the cross-validation code is something that you would post. Well, you would actually train with, right? But also you would use it as an evaluation method. So you would train using cross-validation and use the metrics that were output from the cross-validation training to inspect and see your model sort of on average, how well it performed across the different folds that you created. So you can use cross-validation either just for evaluation, or you can use it as a training. Typically, it's used as a training / evaluation technique. And one of the things to add to cross-validation is it's really, among the many benefits of it, is it allows you to basically train with smaller data sets. So that's one of the benefits, or one of the places where cross-validation might make sense for you to use it.
Malibu woke up from her nap and has come to say hi. This might be her only appearance today.
Malibu.
All right, so next one. Is it possible to specify the number of cores to use for training the model or implement parallelization? That is a hard word to say. Anyone want to take that one?
So I'll say that I don't think that you can specify it. I'd have to check, but I don't think you can specify it. That being said, ML.NET, from my understanding, is multi-threaded by default. So it will try to split up the work among all your cores automatically.
Yeah, and it's using channels, I think, under the surface. At least John has fixed that feature, I think. So
Yeah, that's right.
broke it and fixed it. But yes, I think, and also for anyone, I mean, as Luis said, I think it's multi-threaded under the surface, but you can also do parallelized training if you want to. On your own accord, if you want to start spinning up multiple processes and threads in whatever fashion you want, in like an Akka actor model, for example, or Docker containers, you can do that as well if you want to go on like a higher level, training multiple models in parallel.
The only thing to be aware of there, or to be cautious of, is your data. So the way that the data view works is that it streams your data, right? So if you're parallelizing it, you're going to have to keep track of what data you're using. So with the iData view, that parallelization will take place. But if your data is already split and you're using unique sort of iData views within your different sort of processes, then that's fine. But just keep track that if you're running multiple processes pointing to the same, file or the same data set, you might have a little bit of a hard time keeping track of, which rows in your data set you're using.
Yeah.
All right, next one. Can we use an algorithm for training binary classifiers to construct a multi-class classifier? Isn't that what we just did? I think so. And Rakota, maybe you can clarify that question a bit more. And this was the follow-up.
Yeah, decompose a prediction to multiple binary decisions. You can, and so I think that's what the one versus all did, unless we're misunderstanding the question. And you could, of course, train your own binary classifiers that just, says, is it this class, is that class, and so on and so forth. And you could specify that by, in your features when you're preparing your data and things like that. But the one versus all might take care of exactly the situation that you're looking at, Rakota.
Okay, next one we've got. Do we have any plans for implementing a visualization library in .NET? I guess that's you and me, Luis.
So I can certainly point you to. It's not something that's by default or something that Microsoft. I won't speak for Microsoft because Microsoft, it's a big company and folks are always spinning up big projects. But that I'm aware of, there's no sort of kind of like an ML.NET type project that's being developed for visualization. That being said, there's tons of really great open source libraries that the community has created, right? So you have stuff like Xplot, Plotly, you have Plotly.net, there's GG.net. There's a bunch of really, and they all may vary depending on the scenario that you're using. So that's something that you may want to take a look at. And those are, again, open source, and you can kind of just consume them, right? There's also, there are vendors, right? So something like Syncfusion that, they have components and visualization things that you may integrate into your applications. So whether you want to use the paid support version or open source, there's actually a lot of options out there. And I'm not aware that something coming out of Microsoft is in the works. Again, don't hold me to that. That's just not something that I'm aware of.
Yep. And as part of the tooling team, we are working on adding, and this is in the roadmap, more model explainability, which will come with some visualizations. But that would be, tooling wise, and we're still figuring that out. Yeah, great question. All right. We've got, if we import a model, say trained with TensorFlow, does it need to be converted to Onyx first before loading it, or are there other helpers available? So right now you actually can also load in TensorFlow models, but it's right now limited to TensorFlow and Onyx. Louise, anything to add there?
Nope, I think you covered it. And I think it's called TensorFlow. I can actually put up really quickly to give you the exact name of it.
Was it a score TensorFlow model? Or?
I believe so, yeah. Sorry, through this tutorial. Maybe you can pull up the other question, the next question while you're
not a question, but Bruno was looking forward to the model builder post. So wasn't sure what was new with the new version. And actually, because we have some time, I can go ahead and show you all. For those who are familiar with model builder, I will show you what is new. Because the post probably won't come out till mid to late next week.
And you get this functionality if you install the latest update, right?
Yes, from the marketplace or, extensions manager.
Cool.
Yep.
So the names of the functions or the transforms that you're going to want to use while this is loading, for TensorFlow, it's called load TensorFlow model to load your model, and score TensorFlow model to score your model or use it to make predictions.
Oh, I just realized I don't know if I have my preview VS updated, but let's see. So I'm just going to do so this is what's new. The data page has been changed quite a bit, design-wise and functionality-wise. So I'm going to do taxi fare just as the example here. Data sets and regression. Let's do taxi fare train. So there's a bit more advanced data options here. So you'll select your column to predict. And I think this is an internal build before making the final touches. So let's see that it actually works. Hopefully, cross your fingers.
Bruno is saying that he appreciates the live demo of Model Builder. An unexpected plus.
This is all unscripted, live.
Yeah.
It is. So then, of course, I choose my fare amount as the label. I want to predict what the fare is. So you can actually open this advanced data options, and now you can change the column purpose. So, for instance, we detected passenger count as categorical, but I actually want to count it as numerical. And you can train it and, try out different column purposes, and then data formatting if we get this wrong as well. So you could put, if it has a column header, what the column separator is. And then I know in different parts of the world, the decimal separator is different. So you can specify that as well.
Fantastic.
In case we get it wrong. The other thing is before with SQL in Model Builder, we were loading all of the data locally. Now we're actually going to take advantage of being able to just stream it. So we don't have to download it all locally, which makes a lot more sense. So I'll be coming up with that post soon, but that's and then a lot of bug fixes. But those are the two big features that were announced. So.
It seems like a small thing, but the numerical, for values of thousands and so forth, dots or commas, that's a super important thing. I've been bitten many times of that, using European data sets, for example, and that just having an issue reading the data. So that's great.
Yeah, we actually had a customer who they had such a problem with the column purpose that they made their own Blazor version. I think it was Blazor, but web version of Model Builder so that they could get around it. So, yeah. So that was really, really great.
Right here says live demo on Friday 13th.
It's
That's how
okay
we roll.
because I have my superpowers that a demo has never failed, and it still never failed me.
Always test in production and ship on Fridays.
On the 13th.
Yeah, on the 13th, exactly. Let's see. What have we got? Yes, F# and C# are two friends. We love them equally. We are actually, on my team starting to talk about how we can support F# a bit more. We know that the F# community is mighty and strong and passionate, so that's on the roadmap as well. All right, so we got wait, did we do? No, we just did this one.
I think there's another one.
Custom networks. Is that on the roadmap at all? So we just talked about that. If we didn't answer it, let me know. Okay. Oh,
Angelo, is there a limitation on data set sizes? Not that we're aware of. It's actually fairly ML.NET that's actually one of the advantages, right? And kind of like I alluded to before with the parallelization answer, the data view is made for streaming, or it works really well for when streaming your data, which means that you don't have to have all your data in memory, which then means that it works very well with very large data sets. So is there a data set size? That depends on, if your machine is able to handle all that processing for large data sets. But in general, it works well with fairly large data sets, Angelo.
Yep. Oh, it looks like Jake is on the line, our head and lead engineer for ML.NET tooling. So he was just talking about how Model Builder auto-detects values, so defaults should be right, but if we predict wrong, we have a way to fix it. And then this will also help us in the future be able to predict right even more. So, yeah.
So the question now is, though, is there an ML model underneath the surface that predicts what the default should be like?
Oh, that's not yet, but we could.
I'm curious.
Not yet. So Paul here said, any plans on official Model Builder extension in VS Code? So Fran Silva created one, actually, and we are collaborating with him to make sure that the flow between them makes sense, that the functionality can be the same between them. So we will probably not support, but we won't be the ones to be creating it. We will support Franz in his open source VS Code model builder. But that could change in the future. But we're definitely looking forward to working with Franz on that. And let me actually pull that up.
I'm actually pulling up. I got it.
Are you gonna share your screen, or you want me to share my screen?
So you can share your screen, but I pasted into the chat the link to the marketplace where they can find that.
So this is it right here. I know he recently just had a new update, actually, adding, I think, a new scenario or something. This runs on top of the ML.NET CLI, I believe. So, yeah, so that's how you can get that extension in VS Code. Okay, and I think that's all the questions. So if there's anything else, feel free to paste in the chat. And if not, you've got all of us on Twitter. You've got the Slack channel. And then just if you want to learn more, check out the workshop. I think we have a short link for that, right?
For which one?
Workshop?
Oh, yeah, it's MLNet workshop -content.
Like this? Is this it?
Content, yes.
Okay. Oh, perfect. And then this will be your, and Alexander showed this earlier, but this will be the step-by-step
guide, yeah.
So we kind of did the get started. This will walk you through, you get the iData view, all the different data types we support, all the way down to, deep learning, Onyx, AutoML, data frames in Jupyter, and so on.
Cool. All right. Well, I think we're ready to get this thing going, right?
I think so.
Definitely.
Yeah. So if there's any last minute questions, post them in the chat. And if not, Virtual MLNet community Slack, you can join us there and you can continue the conversation there as well.
Yeah, absolutely. And look forward to seeing all the submissions next week. And again, we're going to announce the winners on Friday next week at 11 p.m. Pacific time. So definitely don't miss out on that, because you will see all submission videos being shown, and we will pick one of the winners there. And don't forget to submit before midnight on Wednesday as well. So looking forward to it.
Oh, just to clarify, you posted 11 p.m. I think in the
Pacific.
chat. 11 p.m.
Oh, 11 a.m. Sorry. Oh,
Yeah, just to clarify, folks, we won't be here at 11 p.m.
11 a.m.
I mean, we've done that before at NDC overnight workshop, but in this case, it's not going to be an overnight announcement.
Yeah,
That's
that would be
2
late.
a.m. for us,
No,
I think.
11 a.m. Thank you for the correction.
All right. Well, I guess we're all good, and super looking forward to looking at all the submissions. Hopefully, we'll get a few new ideas as well. Oh, there goes my AirPod. Malibu, please don't eat that. And yeah, we'll see you all on, when is it? Friday.
Friday, yeah, next
Yep.
week.
All right.
Happy hacking.
Happy hacking, everyone. Goodbye.
Bye, folks.